Okay, so rates of change in kinematics, this is going to be the last part that you need to deal with. Some of this stuff you'll see again in year 12. So if you get this part now, you'll be quite far along the way. Now, solving rates of change problems, it's really similar to the optimization stuff. You don't really need to find any turning points or anything, you just find the derivatives and then you just follow what it says. It's a fairly straightforward thing. Just a reminder, how do you write down rates of change? So if you were looking at something that involves, writing in black is a great idea on the black. Something that involves volume, and it's in terms of x. Can you see it or not? No? Let's try yellow. Better? If we're looking at v in terms of x, how will we write down the rate of change in terms of x? Yep, dv over dx will be our rate of change. Okay? Now, a container in the shape of an inverted right cone of radius 2 centimeters and depth 5 centimeters is being filled with water. When the depth of water is h centimeters, the radius of the water level is r. So if you read the first bit, you need to use similar triangles. Now, always draw a diagram if you need it. Yeah. There's an inverted cone. What's our radius on the top? What's our height? Good. Then, oh, I can't choose all the colors. That's annoying. Then, if we're looking at the center bit, like so, what's our radius? It says on the description, when the depth of the water is h, the radius is r. So at this point, our radius is r, and our depth is h. Okay? Then, we need to express r in terms of h. Now, if I match the ratios of the cones and they're similar, what would I match with what? 2 with the r. Yep, sounds good. What's that equal to? 5 with the h. Now the general rule of thumb, if you're not entirely sure about similar triangles, is match it so that you have matching sides. Then if you're doing a longer side, match it with the longer side on the other one. If you're doing the shorter side, match it with the shorter side. Then from here, how can we solve this? Anyone? Alright, you're not in year 9, so I'm going to show you the fraction way. 2 over r is equal to 5 over h. Then we want r in terms of h. So let's make it so that r's on the top. So flip both sides. Oh, actually, you guys don't like the flip both sides thing. Times it by r. 2 equals to 5r over h. How do we do it so that we're left with just r on one side? No one? Bring h over. Sounds good. So then 5r is equal to 2h. Almost done. What's the last step? Divided by 5. So r is equal to 2 over 5h. That's part A. Then part B. Express the volume of the water as a function of h. Now, if you're not entirely sure of your volume formulas and all of that, I'm going to give you guys the year 12 what's it called? The year 12 formula sheet, which has all of the formulas on the top. Now, the volume of a cone is 1/3 of a cylinder. What's the volume of a cylinder? Yes. If you don't know how to figure it out, you find the area underneath, then you multiply its height. So what's the area on the base? As a circle, pi r squared. So pi r squared, then you times it by the height. Then we know R is equivalent to 2 over 5h. So 1 on 3 pi, we replace this with 2 over 5h, square it. So then if we square everything inside, we get 1 on 3 times 4 over 25 pi h cubed, which then gives us 4 over 75 pi h cubed. Then it says at what rate is the water volume changing. So if we're finding rate of change to depth, what do we need? The V over what? What's the depth? H or R? H. So dH. So if you look here, we take the derivative of that. That's 4 pi over, oh god, what is that? 375, so 321, 225, h squared. Then when the depth is at 1 centimeter, so h equals to 1, you plug in h being 1, so that should be 4 pi over 225. What are our units? What's volume? Centimeters cubed over, you can't even see it, centimeters, yep. Okay, when you rewatch this you'll be able to see it, don't worry. Alright, kinematics. If you're doing physics, this is a really easy bit for you. If you're not doing physics, good luck. No, I'm kidding. If you don't remember what each of these mean, what's displacement? Anyone?
Distance and direction from the start to the end.
Yep, so displacement is how far and what direction you are to the start. To the start. What's velocity? Yeah, essentially speed in a direction, or if you like, I'm going to put this with brackets x. So this is the change in the displacement over the change in time. Now note that I'm not using the dx over dt notation because we're not taking derivatives necessarily. Then acceleration, I'm going to use an a, this one I'm going to use a v, is a change in velocity over the change in time. Any questions? Now notice that you have change in displacement over change in time, as well as change in velocity over the change in time. So these three must be related. Oh, you can't see it. So what's written up there is displacement to velocity, then velocity to acceleration. Okay. If you can't read it, don't worry. You'll be able to see it on your screen. Now, displacement to velocity, it's change in displacement over change in time, which means what are we finding? Yep, linear gradient. So the linear gradient of displacement will give us velocity. And then the linear gradient of velocity will give us acceleration. Fairly straightforward. For some of you, this is just a revision. Alright, that is not very big. A particle moves, I'll read it for you. A particle moves in a straight line such that its displacement is given by the equation t squared minus 4t minus 12, where t is greater than or equal to 0. So A, identify its initial position. What happens when time is equal to 0, in other words? Yep, so x equals negative 12. obtain its velocity and hence state its initial velocity. Now, I said before, the gradient gives you the velocity. If it just asks for velocity, then you need to actually find the derivative. So we need dx dt. So what's dx dt? 2t minus 4. So initial velocity, what's dx dt when that happens? -4. Now this says it's in meters, so it's meters per second. And describe, oh, wrong notation. We're not doing physics. Hence state its initial velocity and describe its initial motion. So if it's got -4 meters per second, is it going forwards or backwards? Is it heading, sorry, is it moving in a negative or positive direction? Negative, because that says negative. Okay? You just check what it is. Anyway, I won't write that bit down. At what time and position is the particle momentarily at rest? What's your velocity when you're at rest? Anyone? Any guesses? Jacob, what is it?
Yes.
If you're at rest, what's your velocity? 0. So 0 equals to 2t minus 4. So what's t equal to? Then we need to find the position as well. So sub that back in the original. 2 squared minus 4 times 2 minus 12 gives you 4 minus 8 minus 12. -20, so -16 meters. Hopefully I didn't stuff that up. So it says at what time. We can find the time using the fact that it's at rest. So our velocity is 0. So then we went through, we found the time. Once you found the time, then we need to check the then we need to check its position, because it also says time and position. So put it back in the position formula with the time. D. Show that the particle is at the origin when t is equal to 6, and calculate the distance it has traveled to reach the origin. So t equals to 6. Now it says to show it, so all you simply have to do is sub it in. Does that give you 0? 36 minus 24 minus 12.
0.
So you've shown it. Then you have to calculate the distance. Luckily, we've already calculated our starting point to the end. So our distance. Now remember, distance doesn't matter which way you go. If you're going from negative to positive, it's the same as you going from positive to negative. We moved 12 meters. E, calculate the average speed. Now we use our change in displacement over change in time. Sorry, not change in displacement. Speed is distance over time. What's our distance? 12. What's our time? How long? 6 seconds. Equals 2. F. Now we use the velocity one. So we're going from 0, and we started off at 12, so minus 12 over 6, giving us also 2 meters per second. And yeah, any questions? This one's fairly straightforward, I'm hoping.